Example 1, basketball at recess. Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at a school for students to use at recess. He presents a plan to install a half-court design as shown below. After checking with the school administration, he is told it will be approved if it fits on the empty lot that measures 25 feet by 75 feet on the school property. Will the lot be big enough for the court he has planned? Explain. So we need to look at a couple of important things on our picture. So here's the size of the picture that Vincent has drawn. This court measures 2 inches by 1 2/3 inches. And we have a scale right here. So when we have drawings or maps, usually there's a scale that shows for every inch or centimeter or some measurement on your picture, it corresponds to an actual measurement, feet or miles or kilometers. So for this one in the scale drawing, 1 inch in the drawing represents 15 feet of actual length. So we're going to be using that information to solve our problem. So the first thing we need to do is figure out what our scale factor is. Now they've given us the scale, but we need to write it like we're used to seeing it in that scale factor. So I want you to start thinking about where you're starting and where you are ending. So for this problem, we're starting at the picture and we're going to end at the property or the actual in real life measurements. So if I look back at my scale, 1 inch on the drawing, so 1 inch on my picture, corresponds to 15 feet of actual length. So on my property, that would be 15 feet. So we know that when we are finding that scale factor, like this would be our x value, and we would end at our y value. So to find our scale factor, I always abbreviate scale factor with SF. You can write it out if you would like to, but know that this is my abbreviation. I'll write it up here so you have it in your notes. So SF equals scale factor. All right, so we would take our y value, our 15 feet, and we would divide it by our 1 inch. So our value of this ratio would be 15 feet per 1 inch. All right, so now we're going to take our picture and I'm going to number my sides. I'm going to call this side 1 and then I'm going to call this side 2 just so we can distinguish which ones we're talking about. So let's start with finding the actual real-life measurements of side 1 of our court. So side 1. So we're going to start with the measurement on the picture, which was 1 2/3 inches. Oh. Here we go, sorry, 1 2/3 inches, and we're going to times that by our scale factor. Remember when we talk about scale factor, when we are applying that, it's always multiplication. All right, so I need to make this into an improper fraction. 3 times 1 is 3, plus 2 is 5, so 5/3 times 15 over 1. I know that these are both divisible by 3, so I'm going to simplify before I multiply. So 3 divided by 3 is 1, 15 divided by 3 is 5, and now I can multiply straight across. 5 times 5 is 25, over 1 times 1 is 1. So in real life, this measurement would be 25 feet. All right, let's look at side 2. All right, so on my picture, side 2 is a measurement of 2 inches. So I'm going to start with 2. I'm going to times that, or I'm going to apply my scale factor of 15. 2 times 15 is 30, so that side would be 30 feet. So if we think about the property, so I'm going to draw a picture. It's not going to be super pretty or great, but it'll get you the idea. So this green represents the property that the school has to put the feet on, or put the basketball court on. I just read the word feet, I'm sorry. So this side length would be 25 feet, and then this side length would be 75 feet. So the question is will that court fit on that? Well, we do have a side that is 25 feet, so we could put that 25 feet here. Let's use a different color. Let's use orange for our basketball court. So this could be the 25 feet for side 1, And then we could go out here 30 feet for side 2. So yes, that basketball court, yes, that basketball court will fit. And actually, if they wanted to, they could put another one in because they would still have a little extra. They could do 30 feet here and then have 15 feet in between. So our final answer is yes, there would be enough room.